Hi, my name is Afonso Ferreira and I'm a PhD student at the University of Lisbon. Today I'll present our recent work on a new algorithm to improve satellite retrievals of chlorophyll A in the Antarctic Peninsula. Phytoplankton are the main marine producers and as such are good indicators of changes in the ecosystem. And for the last few decades, ocean cover remote sensing has become an essential tool for monitoring phytoplankton communities. However, it has its challenges in polar regions, for instance, the extensive cloud cover, the sea ice, the Mars seasonality, and the distinct biooptical properties that characterize these waters. Chlorophyll A is a proxy of phytoplankton biomass, and it has been seen to be underestimated by satellite observations in the Antarctic Peninsula. As such, several regional chlorophyll A algorithms have been developed, and most of these have several limitations. For instance, most calibrate the algorithm using 4-meter-derived chlorophyll A, which can be faulty for more optically complex waters. Most use sensor-specific, most are sensor-specific, or use a small match of data sets or updated ones, and even new studies have reported that there is no chlorophyll A underestimation. We have three objectives. First, assess the performance of current global regional chlorophyll A algorithms. Then, investigate potential factors contributing to this underestimation. Finally, create a new regional algorithm. We use chlorophyll A satellite data from ocean cover CCI 4.2, and we used in-situ data from biooptical dataset from Vanda et al. 2019, and from several cruises to the Antarctic Peninsula from the Brazilian High Latitude Oceanography Group. And we saw that the CCI project, a global project, underestimates chlorophyll A around 50 to 60% in the Antarctic Peninsula, so a strong regional bias. We also saw that current regional algorithms help correct for bias, but the error is still high. So as you can see here, the chlorophyll, the satellite data error, the percentage error of the error, the measurements increase as the in-situ chlorophyll A increases. So we have stronger underestimation as in-situ chlorophyll A increases, as you can see here. When we look at potential factors contributing to this underestimation, we looked at the packaging effect. We showed no significant effects on the bias, and we saw a slight increase in bias for waters close to sea ice, but this could be simply due to correlation with simply more productive areas that characterize these waters near to sea ice. We created a new algorithm, the OC4-SO, which is this thick black line here. There are a few caveats. For instance, we use a small range of data since we use only mainly coastal and productive waters, and we have to be careful with the performance for very high chlorophyll A, very high in-situ chlorophyll A waters, since we need more data, particularly at these high chlorophyll A concentrations. So we have an algorithm that corrects for underestimation in the Antarctic Peninsula. Can it be applied to other regions of the Southern Ocean? Yes, but only for waters higher than 60 degrees south and with caution. We use a small independent data sets, again from the Vanda et al. Paper, and we saw that the OC4 outperformed the CCI global product. We also saw that when applying this OC4 to the time series and calculated the seasonal cycle, we see the real impacts of using versus not using a regionally adapted algorithms. Here we have the OC4 in black line and the CCI in gray line, and we see that there are many differences. First, the difference in chlorophyll A, then we see that if we use the CCI, we see we define no summer peak in chlorophyll A in this region, and the OC4-SO corrects this. So it's just some final considerations. We confirm that chlorophyll A of the Antarctic Peninsula is significantly underestimated by chlorophyll A algorithms. We see that we still don't know which is the factor behind chlorophyll A underestimation, but it does not appear to be pigment packaging effect, which is one of the most popular. Since the factor behind chlorophyll A underestimation is intrinsically related to in-situ chlorophyll A, it could be low particulates backscattering, although more studies are needed. And the OC4-SO exhibits good promising results even for other regions of the Southern Ocean and allows for the correct assessment of seasonal cycle. But more in-situ data is needed, so it's of paramount importance if you want to improve satellite chlorophyll A retrievals in the Southern Ocean, particularly in the Antarctic Peninsula. So I'd like to thank everyone, all coordinators, and everyone that participated. Thank you.